All right, so let's talk about how to install Windows itself. So we obviously are hitting the most popular operating system out there, and there are different ways to install it and implement it and even work with it. So when we take a look at how to implement or install Microsoft Windows, there's actually a lot more ways than you're probably aware of. So we're going to take a look at virtualization, how to install the OS itself, and some of the features of the different versions. So we've gone through what are the different versions and some of the features that are available in all of them, but now we're going to take a closer look at the differences between 7 and 8/8.1. All right, so let's jump into it. Awesome. So we're going to start with client-side virtualization. Now this is pretty cool and something you probably haven't played with before, but we're talking about literally the technological process of creating a virtual version of a computing environment, which means there's not necessarily hardware attached to every OS that you're running. So you can actually separate the elements of a computing environment, meaning the applications, the operating system, documents, programs, whatever, and when you separate those from necessarily running on their own physical piece of hardware, that means that you can have less components and hardware resources and just use additional software resources. Now, does that mean you can use a normal computer to do whatever you want, not necessarily upgrading your hardware? No, not at all. You're going to need a lot of RAM to do this, as well as a pretty powerful CPU to make sure that there's enough memory and computing power to handle all the OSs that you're running simultaneously. So you can increase resource utilization by allowing different resources to be pooled and leveraged in different ways. And that's what we're going to talk about here. And the advantage to this is that you have a centralized administrative place to manage all of these software resources without necessarily having to account for a bunch of hardware resources. All right, so you see two different sides of virtualization on your screen, client side and server. So client side virtualization actually takes place at the endpoint, meaning the computer right in front of you, the desktop environment itself. It can separate the elements of a user's logical desktop environment and the per se physical hardware or the machine in front of you. That just means that your applications, operating system, programs, documents can feel like they're in whatever logical place you put them, even though they're on the same piece of hardware. So with the desktop side virtualization, a single user can run multiple operating systems simultaneously and seamlessly on one piece of hardware. You can actually interact with computers and all of the applications remotely from a mobile device or a completely different computer, which means I could remote in from my cell phone into my computer and control 2 or 3 or 4 operating systems at the same time. It's the equivalent of running 4 or 5 different computers at the same time, but again, one set of hardware, multiple operating systems. Okay, so how do we separate all this stuff? Well, each system is going to maintain their own individual desktop environment, and you're going to have a single centrally managed physical device, one computer, multiple OSs. Now you need some type of manager to make this happen, and we'll get into Hyper-V or, gosh, there's so many options. VirtualBox is a cool one. We'll talk about those. Let's talk about server side first. Server virtualization takes place at a central server or data center. So when you're talking about multiple operating systems in one device, well, we're going to spread that out just a little bit here. That means server virtualization uses one logical device, the server, and that acts as a host machine for all the guest machines. So you may have a screen in front of you and a laptop, or excuse me, on a keyboard and mouse, but your operating system is actually being hosted on a server either locally within your building or maybe even remotely in a faraway place. But nonetheless, you have a bunch of operating systems that are being hosted on this server, and each end user can access one instance of the operating system. And it looks like a normal computer, but again, there's just a lot less hardware involved. So the server is going to house the operating systems itself, and that's the one physical device that's going to host a bunch of logical devices. So since you have a server that's acting as a host machine, all of your guest machines are virtually using applications and programs that are provided by the host, i.e. the server. And then the software application is used to actually divide the physical devices into multiple isolated virtual devices, meaning that each instance of an operating system that it opens is pretty much just like a new window. Even though you see one and the guy sitting next to you see one and the girl across the way sees one, it's still virtual, not necessarily a local operating system. All right. So what's the purpose of all this good stuff? Well, there are a lot of purposes that are going to be beneficial for us to run VMs. We can test new operating systems. We can actually test software applications in a copy of our current operating system just to make sure they play nice together. So testing is probably the leading purpose that we're going to implement here. But we can also run software that's not necessarily compatible with or supported by the OS that we use normally, meaning I want to use a really old piece of software or something that was custom built that doesn't run in my normal Windows environment. All right, so how do we make all this work? Well, I mentioned some type of manager, and that thing is called a hypervisor. Now, there are two different ways to do this, and one is called type 1 and type 2, but we actually call them bare metal and host-based. And host-based is a lot more common for our normal end user that are just getting into this, meaning if you want to implement it, I would suggest host-based. But once you're comfortable with it and you can take those steps, bare metal is actually a pretty cool way to go. Now, a hypervisor itself is really just a VM manager. It's the core virtualization software that allows you to actually run multiple virtual computers on that single physical host. A bare metal hypervisor is the one you install directly on a server's hardware, meaning you don't install an OS first and then other operating systems on top of it. You actually run different OSs at the same time. This is usually the server side. So the host-based is where you're going to be able to run one operating system as your primary, and then you install other operating systems into your VM manager, aka your hypervisor, and then you can run instances of those, meaning they're not running all at the same time, and you may have different operating systems running simultaneously, but they're each in their own little window running on top of what your base or primary operating system is. Now, Linux-based virtualization typically uses this thing called Xen, or it's pretty much a kernel-based virtual machine. They're both free hypervisor systems, Xen XEN, or kernel-based VM, which is actually a KVM, not to be confused with a KVM like keyboard, video, mouse. But anyways, they're free tools that you can embed into the Linux kernel and use in a Linux OS. So some examples if you want to go check them out. VirtualBox, VMware are two of the probably leading, and of course Microsoft has this thing called a Microsoft Virtual PC, and you can run those on top of any operating system. All right, so resource requirements. Like I said, you are going to need a bunch of RAM and a very powerful CPU. Now, before planning to migrate a system from a physical environment to a virtual environment, you need to make sure you have the right hardware in place. And the hardware, I mean, is you need to have something that's capable of supporting your base operating system and your guest operating systems running at the exact same time. So if one of them requires 2 gigs of RAM and the other one requires 2 gigs of RAM, is 4 gigs of RAM enough? Well, 2 plus 2 equals 4, so you probably said yes, but the real answer is no. If you need a minimum of 2 for each operating system, as soon as you start both of those operating systems, well, you can't do anything, which means the minute you open an application on either side, the whole thing's going to fail. So you're going to want to run at more than the minimum requirements all the time. All right, what in the world is an emulator and what do I need? Well, an emulator is the software that's installed that allows the computer to virtually run another operating system, or pretty much the same instance of another instance of your operating system. What do I mean by that? Well, let's say I want to open Windows 7 twice, and I want to open one in a non-networked environment just to play with stuff, and then I want to have a normal Windows 7 that is networked so I can go about my normal business. Well, those are 2 instances of the same operating system. All right, that's cool. So what do I need for this? Well, look at what your absolute requirements are for Windows 7, and then double it, and then probably double it again. That way, both of the operating systems can operate smoothly with more than enough power on the RAM and the CPU side to process all of the requests from both. So if you have all of your antivirus and anti-malware installed on a system, does that mean your VMs get to take advantage of that as well? Well, the answer is absolutely not. Not all virus or antivirus software packages can protect against malware of a VM. In all reality, every VM is a real computer in itself, which means it's going to need its own software. That means you're going to want to install a different version or license of whatever anti-malware you're using, your Microsoft Office tools, pretty much any software application in the VM as well. Now that can definitely get costly, and there are some packages that do cover VMs. So what I want you to do is check the manufacturer documentation and make sure that you're covered, or go get a free version of anti-malware to throw on there just to be safe. You also want to make sure that you have it configured properly. So if you want to restrict users from copying things from your VM to a traditional desktop, meaning your base operating system, or even just sending themselves things from your VM, you have to make sure it's set up properly. Honestly, you would think that if you made updates to your primary OS as far as patches and updating definitions, that everything would be secure. However, I really need you to think of a virtual machine as its own computer. It's going to have its own patches, its own updates, and everything needs to go across both. So your primary updates and just general Windows stuff is going to happen for both your primary OS and your VMs. However, if you're running Linux, Unix, any Apple software, you need to make sure that you have those updated as well. Awesome. So again, network requirements. You've got different pieces of hardware in the real world that you're depending on to make your real computer work. Well, when you have a virtual computer, you need virtual things to make your virtual computer work. So generally for client computers running VMs, the normal network activity load is also going to suffice for the VMs that are initiated on that OS, meaning it can have the same amount of bandwidth and be able to use the network that it's hooked up to. However, you can go a step beyond that, especially if you're going to be running multiple VMs or really high-powered VMs, meaning you can create virtual switches and you can enable virtual machines to communicate with the host computer and other VMs, creating literally an entire network on one piece of hardware. So there are three types per se of virtual switches: private, internal, and external. Oops. All right, let's stay there for just a moment. A private virtual switch is allowing VMs to communicate with other VMs on the same physical host. So you have virtual machines that you're hosting on your own computer, and you have 2 or 3 of them that you want to talk to each other. That's cool. Create a virtual private switch. And a virtual internal switch is going to go above that. So in addition to communicating between the VMs on the same physical host, they can also communicate with the host system itself. So what's the difference there? Well, in this case, and I'll do this on your screen, with a private switch, all of your VMs can talk to each other, but they can't necessarily talk to the physical OS that they're sitting on top of on the physical machine. So an internal virtual switch allows these VMs to not only talk to each other, but they can talk to this computer and operating system as well. All right, an external switch is going to allow, and let me say it again, an external virtual switch. This is going to allow them to communicate with each other, the primary OS, as well as communicate with external systems outside of the physical host. So if you want it to be a full-blown computer, a big real boy like Pinocchio, then you're going to have to use an external virtual switch so that it can get on the internet and network itself. All right, so if you're going to install a bunch of VMs, you should probably know what the system requirements are for each operating system. And I'm just going to focus on Microsoft here because, well, the whole world does. So look at your screen, make flashcards out of these fun things, and let me tell you the important parts because there are a bunch of numbers sitting in front of you. So Windows 8.1 Professional or Enterprise, you want to know how much RAM, meaning 1 gig or 2 gigs, and I would pretty much take note of the 2 gig size here because that's the 64-bit version. You're also going to need no less than a 40 gigabyte hard drive with at least 20 gigs of space available. So what does that mean if you want to install 2 versions of Windows 8.1? Well, the absolute minimum here is going to be 4 gigs of RAM, which means you should be running 6 to 8 gigs of RAM to make this smooth. Also, the minimum required disk space for 2 copies of this will be 80 gigs. That means 20 and 20 available. So 40 gigs available, 80 gigs total. Now, if you have 4 gigs of RAM, is this going to run smoothly for 2 copies of 8.1? Nope, not at all. Remember, we want more than the minimum so that we have room to open applications in our primary and our virtual machines. All right, take a look at Windows 7. We've got Premium, Professional, or Ultimate here. Again, you have 1 or 2 gig versions of RAM, and I would always suggest the 2 gig because, again, that's the 64-bit option. So let's take a look at this required space. 40 gigs of hard drive space and 20 gigs of available. Pretty similar to what you saw in 8. Well, what does it look like for Vista? Well, the Home Premium, Business, and Ultimate editions, both or all 3, use 1 gig of RAM each, and they have to have, again, 40 gigs of space. But this time, only 15 gigs need to be available for the operating system, meaning it takes up a little bit less of that storage space to install the OS. Now, Windows Vista Home Basic, which you probably will not be tested on, but you need to have 512 megabytes of RAM and 20 gigs of hard drive space with 15 gigs open, which is a lot less than the other ones. So before you install any version of Windows, you should definitely be checking to make sure that your system meets those requirements. Now, you can do that by a simple Google search. You can go to Microsoft.com and look for it, but they have this thing also called an upgrade advisor in your Microsoft's environment. So you can look for that in your OS, and it'll tell you all the hardware requirements to install or even upgrade to a different operating system. Of course, this is only Windows tools. So remember that there are different types of ways to boot to an OS. I mean, we could use a USB or a CD. It might even have a copy of our OS on an internal storage drive. But let's go through these with a little bit more detail so we understand. And one of my favorites is PXE or PXE that you see at the bottom there. So a USB is, well, you know what a USB is. You can definitely have an OS and all the system files necessary loaded on a USB drive, and then you can actually boot the USB drive. Now, anytime you do that or use any of these other methods, I need you to remember that in the BIOS menu, you'll have to change the boot sequence so it looks in the right place to find your operating system. Now, if you want to boot to a CD or DVD, then just change it in the boot sequence and it'll look at that optical drive and find the OS file and boot from there. Now, an ISO file, or an ISO file is what we call it, it contains all the contents from an optical disk but in a single file. And usually those files are stored on some type of removable media, or you'll have a local copy on the computer that's right in front of you. So this is actually the most common way to implement a virtual machine OS. So look for something called an ISO file. If you don't have one or don't know where to get one, be very careful when you go to download them, especially for free, because this is a full-blown operating system in a file, and they can come with all sorts of problems if you don't get them from a reputable website. All right, internal and external storage are pretty straightforward. That means it's held on some type of disk drive or solid state drive, and this can be inside locally or an external drive. So a PXE or PXE environment stands for a pre-boot execution environment. Again, pre-boot execution environment. These are OS files with all the necessary support files, and they can be accessed in, again, what we call a PXE environment. This is where the OS and all those files are loaded onto a server, Then the OS is booted and launched over the network interface, allowing the operating system files on the server to be held there instead of any kind of local drive. Now, this is usually what we're going to use when you boot multiple computers that are being managed centrally and they're accessed by more than one user, meaning public computers in libraries or schools, or if you have somebody more on a shift work when you can sit pretty much anywhere in the building. This is when we use a PXE boot environment. All right, so those are the different types or boot methods of where we can find our OS. Well, let's talk about the different installation methods themselves. We can have a clean install, which literally means it's a brand new computer and a brand new OS. We're not really replacing anything or upgrading anything, it's clean. Now, we can also actually use a clean install if we have a lot of old stuff, but we've completely wiped it, meaning there's no history there. That actually is a clean install as well, or at least considered one. So even if your computer is old, as long as you've completely wiped the drive and you have a clean place to start per se, it's considered a clean install. An unattended install is just automated. That means you don't have to stand right in front of it and put in all of the answers one by one by one. This is what we call minimal user interaction. So an admin needs to start the installation, but the tasks actually just play out automatically from some type of answer file or text file that contains all the instructions for the Windows setup. It is really nice to know how to do this if you have to upload, 100 or 1,000 computers. All right, a repair installation is used to fix an operating system that is already installed on a computer and, of course, is experiencing issues. So if you have a repair install, it's going to replace the system files on the current system with pretty much a fresh set. It's going to overwrite those existing system files and make everything right again, and hopefully fix whatever's going wrong. Now, an upgrade's pretty straightforward. This is when you have a version of an operating system already installed, but you want a newer version. So you can do this via a disk or a download from the vendor's website. I would definitely recommend still backing up any data. And that goes for all of these, to be honest. If you're going to do any kind of install, whether it's repair, upgrade, or even just some kind of crazy instance of multi-boot, please have your data backed up because you never know what could go wrong. All right, let's finish the list out. A multi-boot or dual boot means that you're installing more than one operating system on a machine. This means more than one OS made by different vendors per se. So I don't mean multiple versions of Windows here, but I mean one version of Windows, one version of Linux, maybe a Unix install. So a combination of different vendors going on one machine. That's what we call a multi-boot. A remote network installation means that you're going to remotely install, meaning you're not going to actually touch the physical hardware at all. Now, this usually involves operating an OS installation file that's placed on a server and then remoting into that server and pushing an install. You're also going to be using what we call the PXE environment, or that pre-execution environment. That's going to help you actually implement a remote network install. An image deployment is probably one of the fastest ways to use a standardized version and get them on a bunch of computers at once. So the operating system is first installed and configured with all the additional software, the security settings, the user settings, everything. Perfect install. Then you make an image or an exact copy, and you're going to take that and it's going to be replicated onto all of the target computers, meaning all the computers you tell it to. Now, more than likely, the image is going to be much bigger than what you can fit on a DVD, which means you're going to get a big flash drive and push out the install. You just take the USB, plug it into a computer, let it start, and you'll probably have a few USBs with the same image on it so you can deploy quite a few times. Now, the last one on here is called a recovery. This is what's quote unquote a non-destructive refresh. You can repair an install without disrupting any of the settings, the data files, or the installed software that you already have. Now you can only use this on Vista 7 and 8. You can actually use it on 10 as well, but it wasn't available on XP and older. So if you're in 7, you're going to actually use the upgrade option. And if you're in 8, you'll use what's called update and recovery and push forward with those. So that's a lot of info, but it's actually pretty straightforward once you know what they mean. Again, you should be making flashcards, and this is going to help you get through any time that you have to make new installs or upgrades in your environment. So we've talked about drivers a lot, and I want to remind you that the installation files on your OS should already include drivers, but that doesn't mean they're up to date. So if by the time you get a CD or whatever hardware out of the box, there's probably been a more recently released driver for the operating system that you've had for whatever hardware component you're putting in. So don't forget, whenever you're doing an install, go grab the updated drivers. All right, partitioning is a process of dividing a single hard disk into multiple isolated sections, and they actually function like they're separate physical hard drives, but again, it can be on one drive, and it's considered disk partitions. This is what we call it. So this is what enables you to create a logical disk structure and actually organize your hard disks. You can set up and format one or more partitions during an installation, but you can also do it later. I do want to let you know that if you want to do it after installation, you're going to have to format the drive, meaning you're going to lose all the data that's on the drive. So if you know that you need to partition something, well, do it as early as possible. All right, partition information has traditionally been stored in what's called an MBR, or a master boot record. This has a lot of limitations, including the inability to work with anything over 2 terabytes. Now, obviously, as we push forward into technology, our disk drives are getting huge and our solid states are already amazing at storing stuff. So you need to keep in mind when this test was made and what those restrictions are versus what we're working with in the real world today. Again, your master boot record is where we usually store our partition information, and 2 terabytes was the max that it could address. So what are we looking at as far as types of partitions? Well, I want you to take some notes here. First 3 words: logical, primary, and extended. So logical partition is a part of a physical disk that's been partitioned and allocated as an independent unit, and it functions as a separate drive, meaning it's been partitioned and you have maybe C and Y drives where you can just save stuff, local storage. Now, one of those needs to be a primary partition, and this is what contains the file system itself, or the logical drive. Now we have this thing called extended partition, and that means it can be subdivided into different file systems or logical disk drives. And they can be assigned a new drive letter. This is where, again, you have the C colon or F colon, you might have a G drive, whatever it may be. Now there are 2 disk types, and I need you to write this down. One is basic and one is dynamic. So a basic disk contains a primary partition, all the logical drives, and possibly an extended partition. But what matters here is that it can be formatted with a file system and used as a volume for storage. You can only have up to 4 partitions on a basic disk. This is exactly what you think of as partitioning. So let's get fancy with it and talk about dynamic. A dynamic disk contains dynamic volumes, which are volumes that can span multiple disks. Literally different hard disks here, different disk drives or solid state. Which means, let's look at your screen. This is usually what we consider one disk drive or one solid state drive, and we have it partitioned into 3 pieces. What if I told you that right here, where I'm putting my mouse, there's no more room on that drive, meaning we've used up all the gigs or terabytes that it has. And the rest of C drive's contents are actually on a different physical drive. Well, that would be really weird, right? To just put this section on one drive and this section on another. Well, with a basic drive, that's actually not even possible. But with a dynamic drive, you can cut that piece in half and it can look at a different physical drive to look for the rest of the information that belongs here. Now, you can have up to 2,000 volumes can be created, but the max that's recommended are 32 volumes, i.e. different disk sections or drive letters. All right, So we've talked about this stuff called NTFS and even EFS, which is the encrypted file system. Well, those aren't the only two out there. So let's take a look at what these even mean. So during an installation, you choose to format the hard disk with a certain type of file system, and which one is best depends on what you're doing. And some of these are old, but you still need to know where this all came from. So an NTFS stands for New Technology File System. And for a typical Windows setup, this is what's recommended. It can handle what's called FT32, which means there are partitions that are greater than 32 gigs. And because how big our drives are now, this is definitely what's recommended. So let's take a blast to the past for a minute. You see the word legacy, and that definitely means old. So an FAT, or a file allocation table file system, is the older formatting option and should really only be used if you're using an older operating system. So how old do I mean? Well, Windows 95 and Windows 98 would be good options for this. So a file allocation table file is not secure. It's limited by pretty much everything: size, partitions, all kinds of stuff. And you literally can't have a partition that's bigger than 2 gigs if you're on just a FATS file, which means if you want to have a normal size partition, it's automatically going to upgrade to FAT32. Now, there were 3 versions of this: FAT, FAT16, and FAT32. So when we're really reaching back, we're literally talking about that Windows 95, 98 era. When FAT16 came out for the newer OSs after that, and then FAT32 came out, but really we had so many restrictions and we had really surpassed 32 gigs, so that's when NTFS took over. Now, exFAT is useful if you're trying to share external drives between Windows and Mac computers. That's what the exFAT is for, external file allocation table. So this device or drive is formatted on a Windows system, but it has read-write access from a Mac. A CDFS is compact disc. It's really limited and it was developed just for optical disc media. So don't worry about that too much. You're pretty much never going to see it. All right, so let's talk about this EXT2, 3, and 4. Those are for Linux. And there's some previous releases there, but EX4 is the most current you get in a testing environment. And if you're in a Linux environment in real life, you're going to be learning way more than you're going to learn in this course. There is actually a Linux Plus certification if you're ready to deep dive into that. Anyways, it's still supported by the current releases of Linux, and EXT3 is the improved version of 2, and 4 is the improved version of 3. Kind of goes in order. The one that's at the bottom there, the NFS, this is literally for networked file systems. So this is hosted on servers, and this allows clients to access directories and files over the network as if they were stored locally. So what I want you to take away from this are there are different types of file systems for different types of environments. You need to make sure you pick the one that is right for you. Don't forget, if you're ever going to change the file system, you're going to have to completely format a drive. All right, a work group itself is a peer-to-peer network model which computers are grouped together and access shared resources. They might be printers, files, folders, whatever. Members from that work group can access all of these shared resources over the network, and computers that make up a work group appear together when you browse the list of devices, meaning it's kind of a public list as long as you're on that network. Each computer maintains its own user account and database, but if you're a user that wants to log on any computer, you actually have to create an account for that user on every computer of the work group. So a work group is kind of a non-centralized version of a domain. So a domain is actually a client-server network model. It groups computers together for security, and then it has a centralized administration point. So all the computers that are members of that domain, they have access to the shared resources as well as and the database, but individual users can log on to any computer of that domain, and they'll have their own customized settings travel with them. So make sure that you realize that all the administration and management is centralized because you've got to get it set up on the domain, which is on the server, not on every computer itself. Now, domains require a specially configured server called a domain controller and that's where all of the user account databases are stored. Pretty straightforward, simple stuff. Client, or what we call peer-to-peer, which is a work group, and the domain itself, where they have a domain controller and server. All right. So how do we get an even smaller version of that? Well, we have this thing called a home group, and that's a peer-to-peer networking scheme where in a home or grouped setting, you can share all the files and resources, but this is really for a Soho environment. So if you install like a normal version of Windows 7, the home group is actually automatically created, and you're able to join other devices to your home group to share resources. This is just the baby version of a work group or a domain. All right, no matter what you're creating here, there are some things that are going to be the same across all operating systems, and that's the requirement for customizing system settings. That means what language you're in or going to be using, what region of the country. This is going to default to the US, but you have all regions and time zones available. You need to give your computer a name. You've got to tell it what date and time it is, and if you're in a place that adjusts to daylight savings, so it knows to change it for you. It's also going to want to know what your network configuration is, meaning you need to jump online and you're going to have to put in that password and all that good stuff. If you're going to set up a work group or a domain, you need to do it here. So do you have to do it during installation? Not necessarily, but it's definitely smart to get this knocked out and taken care of earlier than later so that you don't have to re-customize any of your settings. So we have all kinds of software that we're installing on our computers, but our OS is definitely going to be the one that runs the show. So anytime that there's an update to either applications or your operating system, make sure that you're installing them. It could be as simple as new features and pretty things, but it could patch some problems and fix security holes that you're not even aware of. At a certain point, the application is no longer going to be able to be updated if you don't update your operating system. So things are dependent on these operating system updates to make sure all your applications run smoothly. Now, as an operating system actually evolves, there are a lot of changes that are going on in technology. So it's always a possibility that your OS needs to immediately update after you install it because it might have sat around on a shelf for a month or 5 months or even come out a year ago before you put it on a computer. So one of the first things you should do after you install an OS is update it. Now, patches are specifically targeted at operating systems, and these are just releases to make sure everything's up to date. A service pack, however, is kind of a bigger, badder patch. It's a comprehensive update that includes all the prior patches and can have new features and functions built into it. So those take a little bit longer, but they're going to show a bigger difference. Now, Microsoft product activation, or what we call volume activation, if you have licensed versions of software, is going to be pretty much the equivalent of anti-piracy, meaning you have a legit copy of the software that you're going to use. And you'll have some type of key or built-in activation code that it's going to be able to see and work with to make sure that you have legitimate software on your computer and you didn't just download it from some crazy place. All right, we are going to end this section right here because you have a lot of new flashcards that you've either already made or need to make, and it's a good amount of information to go over. So if you need to watch the video again, go ahead. But make sure that you're prepared for each of the operating systems breakdowns and knowing the difference between Vista 7 and 8/8.1. I'll see you soon.